In this example problem, we have a study that finds that people are the least happy when they are in their 40s, which is someone who's about to turn 44 at the time of recording this is a little bit of concerning news to me. Also, we have another study that suggests that money does indeed buy happiness, but only to a certain level of income. And after you hit a happy point, pun intended, making more money provides less general happiness to your life. We are asked to determine what's the best model for predicting someone's happiness based upon two predictor variables: how much they make, their income, and their age. For each of these predictor variables, we're going to test to see if the relationship is linear, logarithmic, or quadratic, or polynomial, if you will. And once we have our optimal regression equation, we're going to make predictions for these three case studies that we have here. So the first one I'm asked for is age. To figure out what the relationship is, the best thing to do is make a scatter plot. And when you make a scatter plot in Excel, you want to have your x variable, your predictor variable, which would be age in this case, to the left side of your response variable, which would be happiness. So I'm going to highlight the entirety of the age column until I get this cursor, hold down Shift, and drag it over until I have age on the left side of happiness. And with those two in there, I can highlight all that information with our little Control-Shift-Down shortcut. And I can insert, after I scroll back up to the top, scatter plot for those two variables. And here I have my scatter plot. I'm not going to go too crazy making things look absolutely perfect. What I'm doing here is comparing someone's age against their happiness. First things first, I do want to get rid of this empty space because it's going to make it hard to read my chart with all these blobs in there. So I'm going to go to Chart Elements, and I'm going to go over here and I'm going to format this x-axis first. Get out of here. Stop with the chart elements. There we go. And I'm going to right click on it, format axis, and I'm going to change that lower bound to 30 to get rid of all that empty space on the left side. That looks much better. And now we label this guy up a little bit. This is our comparison of age against happiness. Let me insert some axis titles so I can remember what's what over here. This one over here is the y-axis, which was the person's happiness score, and then, hey, happiness, there we go, and then the bottom was their age. And with all of that in there, now I can find the relationship. Is this relationship between the two best described as linear, logarithmic, or quadratic? So I'm going to go to my chart elements, I'm going to go to my trend line, and grab more options over here, which is going to bring this in here. To figure out what's the strongest, I'm going to display the r-squared on our chart. And right here I have one that's really tough to read, but it looks like 0.0934. Okay. Here, there we go. Open that up one more time. I don't know what happened there. Looks like 0.0934 when you display the r-squared. If you go to logarithmic, it goes down to 0.0518, and then if you go to polynomial, it jumps all the way up to 0.2617. So the highest r-squared is when we do the polynomial or quadratic one. So age is best described as a quadratic relationship against happiness. So I'm going to type quad in up here so I know that when I make my formula. Let me go and hide this guy off in the corner now so I can make another one. Close out this format chart area over here. And now on to income. I want to do the same thing, but this time I want income on the left side. So let me go and highlight that, shift and drag. So I have income on the left side of happiness. Grab all the information for those two variables. Scroll back up to the top, and I'm going to insert another scatter plot. And this scatter plot is income against happiness. Axis titles in here just so I can read this better. The y-axis, as always, is our response variable, so it's happiness in this case. And then down here for our x-axis, the thing that contributes to happiness, which in our case is money or income. So, like before, now that I have the setup, let's determine if income has a linear, logarithmic, or quadratic relationship with a person's overall happiness. I'm going to go to chart elements. I'm going to go down to more options under trend line, and when the screen pops up over here, I'm going to turn on R squared to be able to see it. It looks like it says 0.4189. I know it's really hard to read, but you should be able to see it on your own screen. For logarithmic, when we click on that, it looks like it decreases down to goes up to 0.4439. And then lastly, over here, we've got polynomial, and that's 0.4426. So 0.4439 for logarithmic looks to be our strongest relationship that we have between the two, and we're going to determine the relationship to be between these two to be logarithmic. Close out my options over there, shrink my chart, hide it over on the side for right now, and we have a determination right here. Age has a quadratic relationship with happiness. Income has a logarithmic relationship with happiness. So to make my regression equation, I need to convert those respective variables to what they're going to be. For the quadratic relationship, what I want in this case is the square of a person's age. So I'm just going to click on the age of the first respondent, which is 49, and then raise it to the power, Shift and 6 for the caret, of 2. I'm just going to square that number. And 49 squared comes out to be 2,401. I can fill handle to fill in all that information, and now I've got the square of every single age for the people that are up in here. For income, we determined that has a logarithmic relationship. So what I want to do now is I want to find the log of income by typing equals ln, opening a parenthesis, and clicking on respondent 1's income of 52,000. And when I do that, I get 10.859 and a bunch of zeros. Now I can fill handle all that in, and I get the natural log of each person's income level. And with that, I have the variables that I need. So I can do a regression equation. In Excel, when you have a quadratic variable, like age over here, I know it seems a bit weird, you actually have to input the regular variable and the squared. Reason being is in any quadratic relationship, if I blow this up over here, drag him out a little bit, get it out of the way, does tend to flatten off and be linear in points until the extreme ends. If you use just the square, you're going to get a much steeper curve. So to represent the proper curvature, you will, of your polynomial relationship, you need to use a variable for both what it would be linearly and then the variable that adjusts it based upon the square of that number. So what I'm getting at right here is every time that you have a relationship that you deem to be quadratic, you want to make sure that you use the regular variable and its square when you are doing your regression analysis. So I need to have age squared, a natural log of income. You don't need to do that fancy stuff with a natural log with a logarithmic relationship. We need to have the three of those next to each other. So what I'm going to do is I'm just going to, in this case, drag age over to the side. It's the easiest way to get all three of them in an area where I can highlight everything. And there we go. So now with my stuff set up, I can go to my data analysis toolpack. I'm still doing a regression over here. Delete out what was in there from the last problem that I was working on. I'll leave the labels checked though, because I definitely intend to use labeling for this. And now I want my Y range to be the thing that we are predicting for, which is happiness. So I'm going to grab the entirety of the happiness column, cells C1 to C101. And then for the X range, I am going to have the entirety of the three things that I need for predictor variables, which is age squared, and the natural log of income. So with the way I have this set up, that is cells D1 to F101. I have labels on, so that's good. And for my output range, I'm going to put that in the next closest spot I can, which is going to be cell H18. And when I hit OK, all of my returns come back. And here I can see all of the numbers that we are going to have to work with, which is basically we just need the intercept and the coefficients for each of these variables. So I can go and I can fill them in to my equation. We have a constant of negative 13.30 if I round off. Because age had a quadratic relationship, I need just the regular linear relationship for the variable, which is the age in years of negative 2.4296, rounded off to the nearest 10,000th place. And then I also need a second one for the square of that variable, which is going to be 0.024067, or it rounds off to 0.0241. And then lastly, the coefficient for the natural log of income was 12.7210. And this is going to be my relationship and my equation that I'm going to use to make predictions for the 3 case studies that we have. So to figure out, in this case, what our prediction is for the very first person, I'm going to fill in for this formula the happiness of someone who's 45 years old and makes $85,000 a year. Well, that would be equal to the 13.30 plus, in my first set of parentheses, the coefficient that we have for that variable times, this is age, so the person's age, which would be 45. Plus, in the second set of parentheses, the coefficient for my second variable, which is the square of age, times this person's age squared, 45 to the second power. And then lastly, I'm going to have in the set of parentheses here, plus, open the parenthesis, my coefficient for the log that we have of income, times, since this is a logarithmic relationship, the natural log of this person's income, and that was 80,000. So all in all, your formula should be your constant plus the coefficient for your variable that was polynomial, just times the input that you have, in this case 45, plus the coefficient for the square of age that was polynomial, times the person's age squared, plus the coefficient for your logarithmic relationship that you had, in this case income, times the natural log of the test person's income. When I input all that in, I come up with 69.72. So we're expecting a 45-year-old person that makes 80 grand a year to be about 69.72 happy on a scale of 1 to 100. What about our second person? We need to predict the happiness for a 50-year-old who makes $100,000 per year. Well, let's do the same thing. It's equal to our constant plus, in our first set of parentheses, the coefficient that we have for just regular age times the person's age, which is 50, close the parenthesis, plus the coefficient that we have for age squared times the person's age squared, so 50 to the power of 2, plus the coefficient that we have for income times the natural log, ln, of the person's income, and this person made $100,000 a year, so I can just type in 100,000, and when I throw that equation in there, I come up with 71.84. Let's do the last prediction before I start discussing what our findings are right here, and for this we're going to use our equation one more time. 13.30 that's negative, plus, in parentheses, the coefficient for age times this test subject's age, which is 60, plus, in the second set of parentheses, the coefficient for age squared, times predictor 3, our third test subject's age of 60 squared, plus the coefficient for income, times, since this was again logarithmic, the natural log of their income, which is $125,000 a year. And all in all, when you throw that information into your formula, you should come up with 76.86. So back to the beginning, what are we saying about this findings up here? That people are the least happy in their 40s. Well, I'm looking at our age against happiness chart over here, blowing it up so we get a little bit better view. We are seeing right here that the dip that we have seems to hit its plateau, if you will, its lowest point somewhere in their late 40s, and then it starts rebounding in their 50s. So the chart supports that. The only test subject that was in their 40s ended up with the lowest number that we possibly had. There is definitely something to be said about your 40s being your least happy point in life. What about the second person that said that income increases happiness, but only to a certain level? Well, if I go and I grab this chart, I see right here that that kind of seems to be true. There's a rapid increase with income until you hit somewhere around 100,000, and then it starts to flatten off. You get significantly less happier at that point. And all of this tends to make sense in things that exist outside of numbers. Struggling with money is statistically the biggest factor in divorces. It's the number one reason for divorce. It's also one of the number one reasons for unhappiness. It's not enjoyable to live life when you're struggling to finance your day-to-day, expenditures. But once you hit a certain point where you're comfortable, additional money doesn't really bring you that much happiness. So people tend to get happier and happier and happier when it's easy for them to exist. But when they end up getting rich, for the lack of a better term, additional money doesn't increase their happiness linearly. It kind of flattens off. And for age, when you're younger, you have less responsibilities, less financial commitments that you have, and you usually are starting some kind of entry-level job that's not incredibly stressful, so your happiness will be higher. Then when you get into your middle age period here, that's when you've been working for a while, probably at the same job. You may have kids that are becoming adults at that age, and you got to worry about not only having the time for their activities, but also helping them finance the start of their own life. Several factors that contribute to bringing somebody's happiness down. And then over here, what happens when you hit late 60s? You retire, which will make anybody happy. And hopefully one day when you all retire, you're going to be incredibly happy because you're going to be incredibly wealthy in retirement.